Welcome students. In last class we have read the graphical representation of motion. Today we will read about the equations of motion. So what are the equations of motion? There are three equations of motion. Number one, V is equal to U plus AT. Number two, S is equal to UT plus half AT square. And number three, V square is equal to U square plus 2AS. There are three equations of motion. There are two methods to explain or to elaborate or to prove these three equations. One is graphical method, another is analytical method. Another method is there, that calculus method you will read in 11 and 12 class or 11 class. But here in 10 class there are two methods. But in CBSE you will have one method, the graphical method, by which we will find out these three equations so that we can solve the different numerical problems. So how can we find the these three equations by graphical method? Let us see. What we will do, we will draw a velocity time graph. Suppose this is the velocity, initial velocity u, this is the final velocity v. The body changes its velocity from u to v here in time t. Join this one. This is A, the B, this is C, this is D. So the velocity of a body is changing from u to v exactly at time t. So from here to here, this is u, here to here, this is v, and here to here, this is v minus a, and this is t. Clear? So how we will find? Let us consider a body changes its velocity, you can write speed also, from u to v in time t. That means initial velocity was u, final velocity was v. In time t, the body changes its velocity from u to v. Now, as the body changes its velocity from u to v, u is the initial velocity, v is the final velocity, v is greater than u. As v is greater than u, you can say that the body will have acceleration because the velocity of the body is changing, velocity of the body is increasing, so body will have acceleration. Now see the graph here, this is the velocity time graph, AB is the velocity time graph, and we know the slope of the velocity time graph or speed time graph will give you the acceleration or will give the acceleration of body. So we can say the acceleration of body is equal to slope of AB. AB is the velocity time graph. So how can we find the slope of the AB? Now you see here, A is a point, B is a point, join this line, then find this by this, is equal to, we can find, or A is equal to, I can write this one by this one, BC by AC. Now say BC is what? BC is V minus U. It will be V minus U by AC is what? AC is T. This is also T. That means A is equal to V minus U by T. Or I can write V minus U is equal to AT. Or I can write V is equal to U plus AT. This is the equation of motion, first equation of motion. V is equal to U plus AT, the first equation of motion. How can we find? We just calculated the slope of AB, slope of velocity time graph. Clear? Now, we also have read that the area bounded by the velocity time graph gives the distance covered by the body. So we can write the distance covered by the body is equal to area bounded by velocity time graph. Now see, this is the velocity time graph AB. What is the area bounded? This is the area O, A, B, D. This is the area bounded by the velocity time graph. So this OABD is the combination of two figures. One is a triangle, another is a rectangle. So we can write is equal to, or we can write S is equal to area of OABD. OABD. Now, this OABD figure is the constituent of two figures. One is ABC triangle and OACD rectangle. We can write is equal to area of triangle ABC plus area of rectangle OACD. OACD. Area of triangle ABC plus area of rectangle OACD. Now we can find the area of triangle ABC, half into base into height. So it will be half into base is this AC, height is BC. AC into BC. Clear? Half into AC into BC. Now plus, what is the area of OACD? OACD is a rectangle. So rectangle area will be length into breadth. AC into OA. AC into OA. Length into breadth. Now put the values. Is equal to half AC. AC is T into BC. BC is V minus U plus AC. AC is T. AO is U, or we can write T into u. Which one we can write? Half into, this is v minus u into t, it will be vt minus ut. Okay, we will not write that, we will write, just put a formula. We can write half, this will be v minus u by t into t square. So what we have done? We have multiplied a t in numerator and t in denominator, plus this one is ut. Now see here, v minus u by t is a. So we can write is equal to half a t square plus ut, or we can write s is equal to ut plus half a t square. This is number 2 equation. Equation number 2. So s is equal to ut plus half a t square. This is the number 2 equation. Next we will go to number 3 equation. Same thing, distance covered by the body is equal to area of OABC BD. OABD. Now see, OABD is a trapezium, and trapezium area will be half into sum of parallel sides into height. So we can write is equal to s is, imply that s is equal to half into sum of a parallel side. This is the parallel side. OA is one side, BD is one side. OA plus BD into height. Height is AC into AC. Now put the values, is equal to half OAGU plus BD, BD is V into AC is T, U plus B into T. Now we have V is equal to U plus AT, or implies we can write T is equal to V minus U by A, put here, or we can write S is equal to half V, or this one is U plus B, I will write V plus U into V minus U by A instead of T. So what I can write? This is A plus B into A minus B, A plus B into A minus B, S square minus B square. So it will be, imply that S is equal to 1 by 2A, this is 2A, B square minus U square, or I can write B square minus U square is equal to 2AS, or I can write B square is equal to U square plus 2AS. This is the number 3 equation. Now question will come, at what condition the body will satisfy the equation of motion? There are two conditions. One condition is the body should be in linear motion. That means the body should travel in a straight line. Number 2 condition will be the body should have uniform acceleration. So what is uniform acceleration? That means the change of speed, change of velocity will be uniform. That means suppose I'll erase this. Suppose in 2 seconds goes 10 meter 10 meter per second. Next 2 seconds 10 meter per second. Next 2 seconds 10 meter per second. That means every time the change of x velocity will be uniform. Change of velocity will be uniform means acceleration will be uniform. When the acceleration will be uniform, at that time the body will satisfy the equation of motion. So I think this is clear to all of you. You will do practice this all, and after practicing you can solve them easily, you can write them easily if question will come in examination. Next part of the equation of motion or application of the equations of motion will be taught in next class. Thank you everybody.